Hi, this is Dr. Barrett Givens from Cal Poly Pomona, and this video is going to talk about how to do one of the homework problems from my students' homework about sets. So the problem I want to look at is that to prove that A is a subset of B if and only if A intersect B equals A. The first thing I would hope a student would notice about this problem is that it's an if and only if, which means there are two parts to the proof. So let me write down those two parts, okay? On one hand, we have A is a subset of B implies A intersect B equals A. On the other side, we have A intersect B equals A implies A is a subset of B. And I called them two parts. I noticed on some homework that students were calling them two cases. They're not cases. We reserve cases for a situation where you have like an either-or kind of situation. We call these directions. So these are the two directions. And you can do the two directions in either order. It doesn't matter. But I'll just go ahead and start on the left-hand side here. So on the left-hand side, how should this proof start? It has the form if P then Q, and so we always start by assuming the hypothesis. Assume the P of if P then Q. Alright, so on the left then, it's if A is a subset of B. So that's what we start with. Assume A is a subset of B. Now, we want to prove that A intersect B equals A. And so that's proving that two sets are equal. The method of proving two sets are equal that we discussed is to take an element in one set, show it's in the other, and vice versa. So I'm going to start with an element x that is on the left-hand side of this highlighted equality. So I'll let x be an element of A intersect B. Okay. Now what do I want to get to? I want to get x is in A. That's what I'm aiming for. So I'm going to start with x in A intersect B, and I want to end with x in A. Well, let's go back to the beginning again. X is an element of A intersect B. What is the definition of intersect? X is in A and x is in B. And so we have x is in A, and we're done with this half. Okay, so that tells me that A intersect B is a subset of A. Now I want to do the other direction of that highlighted equation. So I'll start with let x be in A. Okay, and I want to end this part with x is in A intersect B. So I'm doing the subset the other direction of that highlighted equation. Alright, well, I know that x is in A from the beginning. I know that x is in A. I need to show x is in B, and here's where I can use my hypothesis. A is a subset of B, which means every element of A is also an element of B. So A is a subset of B, so this means that x is an element of B as well. And so now I have altogether x is in A, x is in B, and so those two things together tell me that x is in A intersect B. And so now in this part I've completed that A is a subset of A intersect B. Okay, and then finally putting these two pieces together gives me that A equals A intersect B. Alright, so this direction of the proof is completed. Now let's go to the right-hand side. Now on this part, we're going to start by assuming our hypothesis. So assume A intersect B equals A. And what do I need to prove here? What I need to prove is that A is a subset of B. So to prove subset is a little easier than proving set equality. I just have to take an element x on the left-hand side and prove it's on the right. So let's let x be an A. I need to end with, well, okay, so then by the assumption, since A equals A intersect B, that means that I can sort of do like a substitution and say, well, that means x is an element of A intersect B. And so that means x is in A and x is in B. But what am I trying to end with here? I'm trying to end with just x is in B, so that's just the part I'll mention. X is in B. And so A is a subset of B. And we're done with that direction as well. Okay? I hope this helps. The parts of this proof really aren't that hard, but I think the hard thing about this proof is just keeping track of exactly what you're supposed to be doing at each step and what order everything goes in.